section 9.4, equations of tangents and normals. A lot of this involves working out the derivative and the general rule, but let's look at the basics here. Consider this curve in orange and a point P that is on that curve. We can obviously have a tangent line, and as you can see, that'll be in the format y equals mx plus c. The gradient of that tangent line is exactly equal to the gradient of the curve at that point P. What's new here is this idea of a normal line, and there's the normal line. The normal line runs perpendicular with the tangent line. So perpendicular just means at right angles with. So what we can see is that the tangent line has the same gradient as the curve at that point P, and the normal line is at right angles with the tangent line. And here's a little fact. If we take the gradient of the tangent line and multiply it by the gradient of the normal line, then the result will always be equal to -1. And we use this to help us establish what the tangent lines are and normal lines for various situations. And we'll work through those now. Problem 1. Find the equation of the tangent line at the point on the curve f of x equaling 2x squared plus 5x plus 6, where the gradient is 7. So this is a curve, it's a parabola, and at some point or points, we're going to have the slope of this curve equaling 7. And we need to find out where that is, and then establish the tangent line at that point. So we start off with the f of x function. We take the derivative, so f prime of x is equal to 4x plus 5. And we're trying to find the value of x where the gradient is equal to 7. So we make the gradient function equal to 7. We solve for x, and we get x equaling 1/2. So we know that on this curve here, when x equals 1/2, the gradient is equal to 7. So the x value is 1/2. To establish what that y value is, I substitute 1/2 into the original rule f of x. So you can see I've subbed that in, and I get 9. So on this curve here, at the position 1/2, 9, we know that the gradient of that curve is exactly equal to 7. A tangent line. So we need to produce the tangent line. The tangent line is going to be in the format y equals mx plus c, because it's a straight line. The gradient of the tangent line is equal to 7. That was from the original part of the question. And we denote that as being mt, so it's just the gradient of the tangent line. So I've got y equals 7x plus c, where c is unknown. I now substitute a known point that is on the tangent line. And of course that point is going to be 1/2, 9, because that's the point that we've just worked out. So I sub in 1/2, 9. So y is equal to 9, x is equal to 1/2, and I establish that c, the constant, is equal to 11/2. So the equation of the tangent line is y equals 7x plus 11/2. With that bit of information, I need to also work out the equation of the normal line. Remember, the normal line and the tangent line meet at right angles. I apply this bit of a fact here, that the gradient of the tangent line multiplied by the gradient of the normal line will equal -1. So the tangent line is 7. The normal line I can work out as being -1/7. Again, the normal line is a straight line, so it's going to be in the format y equals mx plus c. And I've worked out that that gradient for the normal line will be equal to -1/7, so I've thrown that in here. Again, I need to substitute a point that is known on that normal line, and that is going to be, again, that position 1/2, 9, so I sub that in. And I establish that c is equal to 127/14. And now I've got the equation of the normal line. Problem 2, find the coordinates of the points on the curve where y equals x cubed minus 6x has a gradient that equals 30. So I've got my y function. I work out the y dx, the gradient function, just using the basic rule. I set that the gradient is equal to 30. As you can see here, I add 6 to both sides. I divide both sides by 3. And now I take the square root of both sides. And so notice that I get both a positive version and a negative version. and the square root of 12 can be simplified as being plus or minus 2 root 3. So they're my x values. So at x equals positive 2 root 3, I know that the gradient of the curve will exactly equal 30. And also at negative 2 root 3, the gradient of the curve will also equal 30. That's what I've just found out. I'm now going to substitute those two different x values into the original rule to produce the corresponding y values. So here you can see I've substituted positive 2 root 3, and I end up getting 12 lots of the square root of 3. So one of the points is 2 root 3, comma 12 root 3. So at that particular point, which is on this curve, the gradient will exactly equal 30. I now substitute the negative version of x into the original rule, and I produce negative 36 lots of the square root of 3. So my second point is negative 2 root 3, comma negative 36 root 3. That's the second position where the gradient is exactly equal to positive 30. Please note that this is a pretty tough question involving a lot of mechanical work by hand, just so you understand. Problem 3. Given that f of x equals x squared plus 16x plus 3, find, firstly, for a, the derivative function. So I've got f of x here, and now the derivative. So you know how to do that already by rule. So there's my derivative function. B, the gradient where x is equal to 5. So I need to substitute x equaling 5 into the gradient function. So when x is equal to 5, the slope of that original curve is equal to 26. C, the coordinates at the point at which the gradient is equal to 8. So I take my derivative function, I make it equal to 8, and I solve for x. So x is equal to negative 4. So when x is equal to negative 4, the gradient, the steepness of the original graph, is equal to positive 8. I now take that found x equaling negative 4 and substitute it into the original rule to produce the y value equaling negative 45. So the point on the curve f of x equaling x squared plus 16x plus 3 that produces a gradient of 8 is the position negative 4, comma negative 45. X is negative 4, y is negative 45. At that point, the gradient, the steepness of the original curve, is equal to 8. Problem 4. Find the coordinates of the points at which the tangent to the curve f of x equaling x squared take 4x plus 4 is parallel to the line g of x equaling 2x plus 1, and b perpendicular to the line h of x equaling 3 minus 2x. Let's look at g of x. G of x, straight line graph with a gradient of 2. If the tangent line is parallel with this line, then they have exactly the same gradient. So the gradient of the tangent line must equal 2. Of course, the gradient of the tangent line and the gradient of the curve are exactly the same. So I take my original f of x function, I find its derivative, I set the derivative to equal 2, and I solve for x. So what I found here is that when x is equal to 3, the gradient or the slope of f of x is going to be equal to 2, which is exactly the same as the tangent line equaling 2, which is parallel to this line here, g of x equaling 2x plus 1. But the question is, what is f of x equal to when x is equal to 3? So I take my f of x function, the original function, and I sub x equaling 3 into it, and I establish that it's 1. So what have we found? At the position 3, 1, the curve has a gradient of 2, and this is parallel to the line g of x equaling 2x plus 1. A similar approach will be used for b, finding the point on f of x so that we are perpendicular to the line h of x equaling 3 minus 2x. So h of x, it can be seen that the gradient here is equal to negative 2. If we are perpendicular, then we are meeting at right angles, and perpendicular gradients, when multiplied together, equal -1. So one of the gradients is -2. The other gradient must be +1/2. So we need to work out now where on the curve the gradient is equal to that +1/2. Here's my derivative function. I make the gradient equal to +1/2, and I work out that the x value is 9/4. So what is the y value? I need to substitute x equaling 9/4 into the original rule, and I end up with 1/16. So at the position 9/4, 1/16, the curve has a gradient of 1/2. So therefore, the tangent line has a gradient of 1/2, and this is perpendicular to the line h of x equaling 3 minus 2x.